Welcome. In this video we are going to continue introducing some other functions available in MacCuba. Remember that they can be easily accessed by right-clicking on the plot. In this case we are going to talk about crop, modify data and kill channels. Crop allows us to extract a concrete region of a spectrum. Having this in mind, the application of it is almost the same as some of the functions explained in the last video. We begin by selecting the spectral window we want to extract. This is achieved by holding the Shift key while clicking at the beginning and ending of the window. Be aware that this shortcut is written in the Crop tab. Alternatively, we could always type the values in the boxes if you find it more comfortable. In any case, note that now we have a blue line indicating our region. Sequentially, we need to decide whether it is more convenient to replace the current spectrum by unchecking the crop box or to generate another subtab with the selected region. In this case, we are leaving the box checked. And now we can proceed by clicking on crop. We see that a subproduct called crop is generated automatically. As a consequence, we now have two spectra, which are the original and the cropped one. As the name suggests, modify data will allow us to modify some parameters associated with each spectrum. In the first subtab, we will be able to change the defined wrist frequency in the header. This is achieved simply by typing the value and clicking on the Apply button. In addition, we can mark down a transition of interest. In the example plotted, the line we have extracted earlier might be due to carbon monosulfide, so we could write down the chemical formula here and type the value of its transition. This is approximately 98.980 GHz. Clicking on Apply will again set the change. If we now look at the header's parameters, we see that the rest frequency, molecule and transition columns are filled with the parameters we have just introduced. In the second subtab, we can change the value of the radial velocity. See that the velocity in this example is set to -2.7 km per second, which is the value that is written in this subtab and in the header. We can replace it by entering the new number in the new value box together with its corresponding units. The Apply button must be clicked to set the changes. See that now we have the new value written in the header. The subtab named Intensity allows us to change intensity units of the spectrum. In this way, we can choose between intensity or flux density, clicking on the intensity box and change its units, using the box right next to it, just like we are showing. Note that in units of temperature, we need to specify between main beam or antenna star temperature. By checking Other tab box, we see that the changes are applied automatically on the plot. Moving forward to the next subtab, Operation will allow us to apply arithmetical changes on the selected spectra. The operations available can be accessed by clicking on the Operations box. As we can see, these are multiplication, addition, subtraction, and division. If we choose as an example addition and introduce a value of 5 in the box Value and Units of Kelvin, clicking on Apply, with the box tab Change Intensity checked, will generate another subtab with that name, as we can see. As expected, now we have the same spectrum 5 units above the original. Lastly, the Telescope tab contains information about different single-dish radio telescopes, such as IRAM, Jeves or Apex, as we can see clicking on the Types of Telescope box. In our example, IRAM 30-meter telescope was selected with the corresponding value of its beam size at the frequency we are analyzing, together with parameters such as the beam or aperture efficiency. Note that when we choose a different telescope, the properties of the one that we have selected are automatically introduced in the boxes. In addition, if the telescope is not presented within these options, we can always type the values ourselves. In order to do so, we begin by typing its name in the telescope box and fill the beam properties. Whatever our choice is, clicking on Apply will set the changes in the same way as the other functions. Lastly, the function kill channels allow us to delete data. In the tab that shows up once we open this tool, we will need to choose whether we are deleting one or more channels. In the second case, we will need to select the spectral window we are erasing. The way in which this is done is just the same as other functions such as crop explained earlier, or even baseline. Again, the shortcut is written in the tab. Imagine that we wanted to delete this line. We then press Shift and right-click in the beginning and in the end of the window. We see that we have the data written in the boxes of the window 1. Clicking on Apply with tab Kill Channels unchecked will automatically delete the data within the blue window. We could also need to delete a single channel. In that case, we click on the Single Channel subtab, and then, following the shortcut on the screen, we would select the single value we want. See that the box will be automatically filled, just like in the other case. Clicking on Apply will erase the channel selected. And that's all. Thanks for watching.